All right, moving on in chapter 3, we're going to 3.6, combining functions. We are looking at if you have an f of x and a g of x, how can you combine those? And we're going to start today with just addition, subtraction, multiplication, division. So we're going to combine them by algebraic means. So today is by algebraic means. Tomorrow, we're going to substitute one inside the other. But for today, we're going to combine them with addition and subtraction, multiplication, division. And the beautiful thing about this particular section is that it's very straightforward. So on the left-hand side, I have written out what we're looking at. So let's say that we have f of x and g of x. Let's say that we say f of x equals 5 and g of x equals 7. Okay, so we've got these two functions. They turn out to be 5 and 7. Let's even make it more specific. Let's say that f at a particular value. So f at 2 is 5 and g of 2 is 7. So what we're going to do is we're going to go through all 4 of these different scenarios. We're going to add them, subtract them, multiply them, and divide them. So writing them out, it is just as intuitive as you would think. If we write the notation f plus g of 2, and we say this in words, function f plus function g at x equals 2. And we say that in shorthand. We don't actually say f, but we say f plus g of 2. This is not multiplication, so this is not multiplication. It is not, so it's not f plus g times 2. It's not times. Nope, not. Okay? What it means is, let's look at what the function f is and the function g is at the value 2, and let's add them together. So here we go again. F plus g of 2 means f of 2 plus g of 2. So we go find the function named Frank. Here it is, Frank at 2. And then we add it to g at 2, g of 2. So basically we're substituting. F of 2 is 5. G of 2 is 7. We're adding them, we get 12. Hopefully that feels very straightforward. Next, we're going to say, well, what if we say f minus g of 2? So of 2, not multiplied by 2. That means that we're going to find f of 2. We're going to subtract g of 2. So we go find these functions. Here they are. We write 5 for f of 2. We write 7 for g of 2. We're going to subtract them, and we get negative 2 this time. Then what we can do is we can say f times g of 2, otherwise written as fg of 2. So sideways next to each other means multiplication. Closed dot means multiplication. And this simply means f of 2 times g of 2. We're going to substitute them in. F of 2 is 5. G of 2 is 7. I'm going to put parentheses to indicate multiplication, and this is 35. The last one is division. F over g of 2. That means f of 2 divided by g of 2. We're going to substitute things in. F of 2 we know is 5. G of 2 we know is 7, and that's it. That's all we can do there. Note that on the side here, when I've given you kind of an overview of what we're talking about today, I've said that g of x cannot be 0. So that's one of our rules, is that the denominator can't be 0. That's a mathematical rule for all time, for every situation. So it applies here. It doesn't matter for this particular example because we said that what we're plugging in is 7, which is not 0. But if I didn't know that this was 7, if there was a possibility of it being 0, I'd have to make mention of that. And we'll see that in a little bit. So what we're doing is we're combining functions through addition, subtraction, multiplication, and division. So combining them with these methods. And basically, we're going to do things like add like terms. That's okay. Add like terms, which means that we add the coefficients if we have the same base and same exponents. So if we can say same base and same exponent, we can add or subtract the coefficients. So that's basically what we're doing as far as addition and subtraction. With multiplication, we'll use exponent rules. For division, we might have to simplify with division, always knowing that the denominator cannot be 0. So it's not equal to 0. Let's recall domain rules real quick. So domain rules, there's 2 of them, and then the third one combines them together. So number 1, recall that the denominator cannot be 0. So if you take the denominator and set it equal to 0, you can find any values that might break it here. So this breaks the math. Number 2, square roots or even roots cannot be negative. So you can't, it's not allowed to have the square root of -4. So that's not allowed. Or the fourth root of -1 is not allowed. Or the sixth root of -1 is not allowed. So even roots. Odd roots are fine, but even roots cannot be negative. We're not looking for imaginary numbers here. We're looking for real things and real problems at this point. And then 3, we can't have, if we have a root, an even root in the denominator, it cannot equal 0. Okay, so square roots of, so the square root of 0 is 0, and that's okay. But in the denominator, it's not. So in the third rule, if you had 1 over the square root of x, x cannot be 0, and x cannot be negative. What does that leave? That leaves x to be, so x must be greater than 0 for this particular example. All right, so domain rules. We're going to need that as we look forward to these problems. So in our second example here, I have different f and g, and this time they're not just numbers, they're whole functions. So I'm actually combining functions at this point, and I'm going to look at what it is for all x, not just at 2. So I've written out f of x equals 4x squared minus 1. F of x, 4x squared minus 1. G of x equals the square root of x. So write those down. And we're going to go through all, we're not going to do division at this point for this particular problem. We're going to do addition, subtraction, this is addition, then subtraction, and multiplication. And we're going to talk about domain for these. So f plus g of x means we're going to add f of x, 4x squared minus 1, plus g of x, the square root of x. We would add like terms, but this doesn't have any like terms. The square root of x is x to the 1/2 power, and so none of these have the same base and the same exponent. These two have the same base, but different exponents, so we can't add them. So this one's done. This is the notation for f plus g, where we've done that part. The domain for this problem takes on the domain for the square root of x, because now this combination, although this one is all real numbers, this one is limited to x must be greater than or equal to 0. And it's okay for this one to be 0. It just can't be negative. It's in the numerator. There's no denominator here. So the domain for the two of them combined has to be the most limiting one, which is x is greater than or equal to 0. So when you add them, you have to consider the new domain for the new function. If we do subtraction, that looks like f minus g of x. So I'm going to write down f first, 4x squared minus 1. I'm going to subtract the entire g function. So it's helpful to put that in parentheses to make sure you would change the sign for anything in g. And I've written out, there's nothing else we can do here. But we can write out the domain, and the domain is exactly the same as addition, x greater than or equal to 0. So you look at each term and you see which rule it might break. This is the only one that might break a rule. We can't have negative numbers. That's why the domain is limited. So if we graph this, it won't have anything. There won't be, there's no graph over here, because these are negative x values. It will have something at 0 and something positive to that, but on this side there'll be no graph. Let's look at multiplication. F times g of x means write down f, 4x squared minus 1, and then multiply it by g, so the square root of x. So let's go ahead and multiply that out, because that's going to help us with our exponent rules. So we're going to distribute the square root of x over both of them, but it's weird to have x squared and then this without the exponent written explicitly. So let's change the square root of x to be x to the 1/2 power. 4x squared minus 1 times x to the 1/2 power. Remember, that's an understood 2 here, and roots go in the bottom, so 1/2. Then when we multiply these two together, so we're distributing but kind of backwards, like this is on this side, we have 4 times 1 is 4. X squared times x to the 1/2 means keep the base and add the exponents. So over here I'm going to write 2 plus 1/2. That is equal to 4 halves plus 1/2, or 5 halves. So we keep the base, add the exponents, and then we say negative 1 times this will be negative 1 x to the 1/2. You're welcome to write the 1 or not. It's up to you. Now this domain is also limited because both of these are square roots. They have a 2 in the denominator. Remember, the bottom is the root. So even roots must be greater than or equal to 0. If this had been in the denominator, it would just be greater than 0. But this is the domain for multiplication. In order to help you understand what you're doing for your homework, I've got an example written down in each section. So number 8 says, here's a function f. It's 6 minus x over 2. G of x is the square root of x over negative 4. And they want you to evaluate adding it, subtracting it, and multiplying, dividing at x equals negative 1. So the first thing I want to do to make this a more simple problem is I'm going to go ahead and figure out what if I plug in negative 1, what I'll get. So over here, f of negative 1 means the function value. Here's f, 6 minus something over 2, and I'm supposed to put in negative 1 here. So that's equal to 6 plus 1 over 2, that's 7 halves. So I know what f of negative 1 is. G of negative 1 means this function, the square root of something over negative 4. And I'm supposed to plug in negative 1, so here it is. Now I have the square root of 1/4, because the two negatives cancel. And that's the square root of 1 over the square root of 4, so that's 1. The square root of 4 is 2. So now I know what g of negative 1 is. So now I need to find out adding the two f of g's at -1, which we figured out. That means f, so 7/2, plus g, which is 1/2. These have a common denominator, so I'm going to say it's 8/2, which is 4. For the next one, I've got f minus g evaluated at the same value, -1. So I'm going to go, again, straight from what it says. F of -1, 7/2. Subtract g over here, 1/2. 7 minus 1 is 6. Halves, which is 3. Now I need to do multiplication. Fg at -1. That means f of -1, 7/2, times 1/2. 7 times 1 is 7. 2 times 2 is 4. And now we have f over g evaluated at -1. That means f of -1, 7/2, over g of -1, 1/2. The rule is with fractions, we keep the top. We change the bottom to be multiplication and flip it over. These cancel and we get 7. There we go. So you want to write down your functions. I want to see all of this work on your paper. So write down the two functions. If they ask you to evaluate it at a number, then go ahead and figure that out, because then you've already done this math. All you have to do is add, subtract, multiply, or divide them. Okay? So that's number 8. Some of the problems are graphs, and they work exactly the same way. The only difference is you can't plug into the equation. Instead, you look at the graph. So we've got two functions for number 12. We have the f function graphed here in purple. We have the g function graphed in blue. And we're evaluating it at -1, just the same instructions as given before. So for number 12, we have to go find, we have to add them together. That means f of -1 plus g of -1. F of -1 is look at the purple graph and find -1. So at -1, this function is at -2. Then you go to g, you look at the picture that's labeled g and find -1. That's here, and go up to the blue graph and it's 1. So what do we have? We have -2 plus 1 is -1. The next thing we did, this was A. B, we're finding subtraction. F minus g at -1. So we've already found f of -1 and g of -1 from our graph. It's -2 and +1. So -2 is this value on f. I have g is +1. So here's -2, there's the minus, this one is +1. And then I get -2 minus 1 is -3. F times g of -1 means f at -1 times g of -1. My notation got a little weird there, but it's the same number. So f of -1 is -2. G of -1 is +1. That's -2. And division d f over g and -1 means f of -1 over g of -1, which is the same values it's been for the entire problem. -2 divided by 1 is -2. Okay, so looking at a picture or plugging in the equation is the same thing. You find the x value that's been requested by the problem. So this one was -1. Either you plug it into the equation plug into equation, or find the y for x equals the value. Okay, so that's what you have to do for these problems, and then you've got one where you need to talk about domain. So be very careful about writing these out. Show all your work so you can see your addition and subtraction, and then we will look at composition of functions in the next lesson. All right, thanks.